Hi, welcome to New Electromagnetism version 5 experimental supplement. This is the first release of the experimental supplement where we're going to talk about the PDX1 experimental results using the new Physics 2 software. This is the abridged version of this video. The unabridged version is for Patreon members only and will only ever be for Patreon passengers and above only. It has a lot of detail showing how to use the Physics 2 software in regard to this, and also how to use some other features of the software. So the PDX1 is basically a homopolar generator. These are the dimensions used in the simulation. This is your magnet. Okay, this line here represents the path through a conducting disk that would be an eighth of an inch off the surface of the magnet, and this represents the closing path. This is the axis of rotation. Okay, we're going to get into more detail of how this operates in a moment. Okay, now the reason why this came about is because the Physics 1 software I spent about 3 weeks trying to get all the bugs out of it for the Paradox 2, 3, and 4 experiments. Paradox 2 is this variation of a rotating system of two magnets, where the magnets normal is in parallel with the axis of rotation. And then there's variants of this, like in one case, one magnet is flipped, and there are the other magnets missing, so we're only using one magnet. And then there's other variations with different types of loops. Okay, and then you have the PDX3, where the orientation of the magnet is orthogonal to the direction of rotation in one dimension, and then the PDX4, where the orientation is orthogonal even to that. Okay, and this is over 54 different variations of the paradox, 2 through 4. And then there's another, I think, 18 other variations where we flip everything, invert everything, where instead of the magnets moving, it's actually the closing path that moves, just to make sure we have complete reciprocity. Okay, and the results here, the red line is the proper output for these experiments, and the black dots are the simulated results that match the experiments. I think 30 parts per million or 60 parts per million we had the results down to. Anyway, so the natural thing now is once I get all the Paradox 2 through 4 experiments being represented properly by the Physics 2 experiment using New Electromagnetism version 5, mind you, the natural next step was to go back and see if the Physics 2 software will give the correct answers for the Paradox 1. Okay, the Paradox 1 was shelved over 20 years ago, and I'll explain why in a moment. Okay, and it's also known as Faraday's final riddle because in this particular experiment, the Paradox 1, which is Faraday's final riddle, we have 8 variations of the experiment, and I'll explain those in a minute. Let me show you what the experiment consists of. It consists of a disk magnet, and we're showing that the axis of rotation is going up. Okay, and this magnet has north side up, and the magnet is attached to a motor, so either the motor can spin or it won't spin. And at this point, we're just using 4 turns per second in the simulation. It doesn't matter. Everything's proportional. And then you have a conducting disk, which is also attached to a motor that can spin or not spin, and it spins in the same axis as the magnet. And then you have a closing path, okay, which is a wire brush that has conductive to the center of the disk, through a voltmeter, and to the outside of the disk. In fact, the plus side of the voltmeter is here. And so when this is also attached to a motor, it can spin. But when it spins, the brush at the center stays at the center, and the brush at the outside whisks around the outside. Okay, and so there's 8 different variations of these 3 components spinning. And this is what the experimental results look like. Now, what I have here is I just have one to show full-scale results. For the dimensions I showed at the beginning, these would be 3.94 millivolts, and these would be minus 3.9 millivolts. This is called normalization. Easier to look at the one than have all these digits coursing through your brain. But the important point here, the reason why this was called Faraday's final riddle, if you notice these block of 2 lines here, that for the disk rotating and the closing path rotating or not rotating, you get no measured output. And this is true even over here if the magnet is rotating or not. And that's the key for every pair of lines going down. In this one here, the disk is rotating and the closing path is not rotating, and you get the full scale output. And that's independent of whether the magnet is rotating or not. Again, for this line, the magnet is stationary and the closing path is rotating, and you get negative full scale output irregardless of whether the magnet is rotating. Same down here, when both the disk and the closing path are rotating together, you get zero output irregardless of the speed of the magnet. And you don't have to make the magnet rotate or not. You can make it rotate backwards, forwards. These results do not depend on the velocity of the magnet whatsoever. Okay, and that was Faraday's final riddle. Does the magnetic field rotate with the magnet? All right, so that was that. That's not really important to us now, okay, because when you look at the simulations for the Paradox 1, these simulations were done with the old Physics 1 software, which could do classical with a stationary field. This is where the field rotates with the magnet. This is where the field doesn't rotate with the magnet. We got same results as new electromagnetism version 3. That's why these are grouped into the same block. And this is new electromagnetism V5 results, and it's shown here. Now, let me normalize this. Let's divide everything by 3.94 millivolts so it's easier to look at this data. So what we learn here is that at this part here, this total is the sum of the voltage in the disk and the closing path. That's what this is. That's the sum total. And this total is the part you can actually measure. Okay, so the parts you can actually measure from all three, or actually all four theories, gives you exactly the same results. And over here, this is the list of what's turning or what's not turning. So if it's green and yes, that means that that particular component is turning. The A, B, C are explained in the unabridged version of the video, where we actually show you how to use the Physics 2 software to compute the results for new electromagnetism version 5 and how to interpret what the results look like when it comes out of the software. Okay, but in any event, here we get the same we get a thing that when you look at the voltages that are what's happening in the disk or the closing path, you get different answers based on your theory. And that's very compelling. And you'd be like, well, you know, now let's go back now 20 years. 20 years, we're going to go back. New electromagnetism version 5 was not available back then. Let me go back to this. So the question is, why can't we measure these? You know, if we could measure the disk, then that would tell us everything. Well, the problem we had back in the late 90s is I was trying to avoid going into surface mount. Even the things that were available in surface mount are very small electronic components, weren't really that good yet. And not only that, so we needed a small circuit to do this, and we needed a humongous magnet. And you really couldn't get large neodymium magnets. I mean, you'd say, oh, you go to Amazon. Well, Amazon back in the late 90s was only a bookseller that was just starting to carry music CDs. And so the Amazon we know today, the 800-pound gorilla that you can get pretty much anything, was not at that state yet. And so, and the other reason why I didn't really care for this is because even if I were able to show that there was no voltage here, and there is a voltage, you know, if there was no voltage on the disk for this particular state of the system, it wouldn't matter, because then people would say, oh, it's just classical theory and the field doesn't rotate. I mean, that would have been great, because that would contradict what classical theorists believe, but then that wouldn't be a thing that would prove invariably new electromagnetism version 3. So me spending effort to do the measurements here at this point would not have been a benefit for new electromagnetism. And so that's why this was shelved. So what we're saying now is that these guys, new electromagnetism V3 and classical physics, where the field remains stationary regardless of the spinning of the magnet, is off the shelf for certain reasons. And that leaves, and this guy cannot be the real thing, but we're going to do a PDX1 experiment anyway, just to show that, like for this case here, that when we're rotating the magnet and the disk together, okay, this is the critical measurement here. Classical theory says, well, if you rotate the magnet and the disk together, you should receive no voltage, where NeV5 shows 73% of your full-scale output. That is a compelling result that will explain one, and it also it also dissuades this one, because here you get 100% of your full-scale output. Okay, and then we can also do this one over here, where we're measuring just the voltage in the disk. We should get 27%, negative 27% of your full-scale output, which would also be discriminator. Now, the reason why it's going to be between these two, it can only really be this one. I know this guy is, even if we get different results from this, it means there's something else that we're missing. It can't be classical theory, and let me explain why. Okay, this is a simulation. I did this with the video for the unabridged, but I went over in more detail. And what I'm going to show you in this video is this is the field when the magnetic field moves with the magnet. So this is the magnet rotating. And if the magnetic field lines had to rotate with the magnet, that means every point at every far distance has to keep up with the spinning magnet. How does that information get out there? That is a violation of locality. Also, at far distant points on this field line, it could potentially going faster than the speed of light. Okay, so there's many various reasons why this classical theory that the magnetic field has to rotate with the magnet is illogical, and it's a violation of basic physical checks. Okay, and new electromagnetism V5 solves this problem because it, in fact, is an emission. And let's go to an emissive field. Okay, so if we're an emissive field, as we're rotating, you can see that beautiful spiral where we see everywhere in ethereal mechanics. Spirals, vortexes. And so if the magnet stops rotating, the field line, the energy, the emission, the information that is emitted, this could be a propagation. I'm very sure it's a propagation of information through the medium. Okay, just has to propagate away at the speed of light. Then if the magnet starts rotating again, that information that the magnet's rotating has to be transmitted at the speed of light. Okay, therefore you do not have any violations of locality, causality, and the speed distance tell. And that is the reason why I've been looking for a new electromagnetism version that has this emissive field that can also get the same answers. Very important that we have laws of physics that don't violate the rules of acquisition. Okay, that's all I'm going to talk about. In the unabridged video, I go through all the variations up here. And I give you a much bigger show on this. So that's why this has to be right, and this can't possibly be right, but we still have to test it. Okay, because if we get something other than 73% on the disk, then we may have another field theory altogether. And this shows you, this is very important, the first rule of acquisition is just because you get correct answers does not mean your theory is true. So you can see here we got 4 different variations that give us the exact same results that we could measure. The possibility that this isn't the end yet is still there. Okay, we have to keep our eyes open, because that's why I'm on the 5th version. Okay, it's actually the 3rd version, but we won't get into that now. Version 4 was basically just a revision to number 3. So any version 3 and version 4 were really the 3rd version. And I should have just said 3A for 4, but bridge under the water. Okay, so now that the Paradox 1 is back it's back off the shelf, we're going to start doing work on it. And we're going to be, because of what we learned from new electromagnetism version 5, we have a simplified form. And because of technological advancements we have available now, our job should be a lot simpler. So what we're going to do is just get a big, humongous neodymium magnet. This is 6 inch by 1 inch. I stretched the picture so it doesn't look proportional. It looks thicker than it really is. I have a 4-inch one in stock that I'm going to try on this first before I spend $620 on this one here. And what we're going to do is we're going to build a turntable to rotate this magnet. So the axis of rotation will be going up, just like you saw in the diagrams above. And we're going to have a WISP, a wireless instrument sensor package, which is going to be made all with the state-of-the-art surface mount parts we have available, trying to keep it in a very, very small package. This is just an artist rendition of that. Just a picture of somebody else's little CPU board. And it's going to be basically duct taped to the surface of the magnet as we rotate it. The input is a differential input. So we're going to have one wire going toward the center of the magnet, the other wire going toward the outside of the magnet. These wires will be insulated. Nothing will be making contact with the magnet. And then this will have a little Wi-Fi radio that will transmit back the reading that it's getting so that we won't have to have an issue with the closing path. We're also going to make this smarter. We're going to put an inertial navigation thing on it so it knows when it's spinning to speed to take the measurements. And then we slow it down. Then it will transmit the information so that no one can make the argument that we're reading the EMF induced by the transmissions of the radio that's on there. So yeah, we have to, when we do circuits like this, things like this, we have to go to the levels beyond what normal physics have, because anything that they can use to say this is an invalid measurement, they're just going to stop there and their eyes roll back in the head. So we have to account for everything they could possibly argue. So that's why we're going to such extremes. That's why this isn't going to be a simple build. Okay, but so this Paradox 1 experiment, it's calling it Paradox 1B, probably won't be till a year away from now at least. Okay, I am getting tired of YouTube not putting my videos out anywhere. So I'm on Twitter now, and I just opened a Rumble site. This might be the very first video I post on the Rumble site. If you want to get to my YouTube, just go to EtherealMechanics.com. That should get you there. The Patreon site is the one I update the most. A lot of these other things, including the Distinti site, are out of date as far as the content. I have to update all of this stuff to put all the new stuff out, yada, yada, yada. But if you want to see the latest up-to-date stuff, for as little as $5 a month, you can see everything that's going on. Except for you won't get access to the source code or anything unless you become an engineer or above. Anyway, thanks to all my Patreon folks. You guys are just the best. No more voodoo physics. Thank you.